Hello, this is Murat Tanik. Today I'm going to talk about Society for Design and Process Science and the mathematics of convergence. Convergence in our mind is the intersection between Society for Design and Process Science and the UAB Integrated System Center. History of convergence is articulated in this book, The Idea at the Heart of Science. In addition, National Research Council presented a report called Convergence, and they define convergence of the life sciences with fields including physical, chemical, mathematical, computational, engineering, and social sciences is a key strategy to tackle complex challenges and achieve new and innovative solutions. SDPS, Society for Design and Process Science, started approximately 25 years ago while I was in University of Texas, collaborating with Stan Getchell and Dr. Kozmetsky at the university. I dedicate this talk to the loving memory of Dr. Remo Murthy, my grand mentor. Presentation is based in many publications. I say these are the selected ones, starting in 1997 publication, a discourse on scientific method for the integration age, which was putting the philosophy of Society for Design and Process Science and convergence, and all the way up to 2007, some mathematical aspects related to this. In addition, presentation benefited from these doctoral theses, starting again with my doctoral thesis, 1978, all the way up to 2018, Dr. Saleh's doctoral thesis. This presentation benefited from the book I published in 1991, Applications of These Ideas into Computing Principles in Software. The mathematical aspect of this rests in the communication channel. Communication channel is a concept developed by Shannon in the information theory, and SDPS logos based on this channel concept. On the left, you see the Shannon's communication channel diagram stylized inside the triangle and then eventually turned into a software engineering society, which is a society inside SDPS. Communication channel model also stylized in the Society for Design and Process Science logo. The one on the left looks like a polygon. It's called a regular polygon, but it is essentially a communication channel represented in terms of the stylized polygon. SDPS logos evolved over time, and this shows the evolution of the logos. It took 200 years to develop the concept of vectors and being used fundamentally in famous theories of Maxwell, electromagnetic theory, and Schrödinger, and beyond. The history of vector analysis is given in this book by Michael Crow. And of course, Oliver Heaviside utilized vectors to represent Maxwell equations. The other picture shows Schrödinger equations. After 200 years, a vector notation is modified by us. We call them timed vectors. Essentially, a vector has magnitude and direction. And 200 years, it's used like that. There is a direction and magnitude. But the frequency, or cycles per second, time, is not inside the vector notation. In this particular diagrams, the one on the upper part, a low frequency diagram, the one on the bottom is the high frequency diagram. And we call this timed vector formalism. What we did, we introduced Fourier series inside the vector. As a result, we were able to capture the time inside the vector as well. Therefore, by using this particular formalism, we were able to represent multidisciplinary mechanisms using communication channel formalism. This is how it happens. Communication channels in the between, and the particle behavior captured by all the way from Galileo, Newton, and Einstein, and the wave behavior from Faraday to Maxwell and beyond is special cases of communication channel as represented by time vectors. Therefore, in the extreme high frequencies, it exhibit particle behavior, and the lower frequencies in the Fourier paradigm represents the wave behavior. As a result, we were able to represent, in theory, all the way from electromagnetic on the left side, radio waves all the way to gamma rays, and after that, particle behavior in physics, electrons, and all the way to atoms, and the chemical substances, molecules, and other substances, and biological life forms. And this whole spectrum can be represented in theory by communication channel formalism. This essentially what we call convergence of the disciplines. Our neurologist colleague, Frank Skidmore, and the other physics colleague, Frank Wilczek, they collaborate on these principles, and we were invited to visit with them in the Arizona State University SciHub. Dr. Wilczek invited us to serve in the advisory board of that institute. And here's a picture, a happy moment with Dr. Wilczek, Tanik, and Michael Lipscomb. And there is another moment captured in the Integrated Systems Center. Dr. Skidmore, Dr. Laurent Penn, and Dr. Alexander in the Integrated Systems Center in some heated discussion. UAB's Integrated Systems Center is organized many years ago, but right now being run by Dr. Dana Slavinsky and Tanik. It's a truly convergence fashion. A work in progress discussion show on the Integrated Systems Center board. Dr. Ray Minier, founder of software engineering in the United States, visited us in the Integrated Systems Center to discuss some of our latest activities. We think we put the science in the Society for Design and Process Science. We propose to share our final results in a few months. The way Society for Design and Process Science was introduced, first idea was, let's develop a society for design, and then we said process, because design and process cuts across all disciplines. And that is why we named the Society for Design and Process Science. This presentation is not about Society for Design and Process Science, nor Integrated Systems Center. We have other presentations about Society for Design and Process Science, as well as Integrated Systems Center. This presentation only shows the convergence aspect of the collaborations in Integrated Systems Center and Society for Design and Process Science, and the mathematics of convergence being the communication channel. This particular diagram is integrated communication channel formalism. And there is another one, this diagram also integrated communication channel. Mathematical aspects of this talk can be questioned by sending an email to mtanik@uab.edu. Thank you very much. If you have any questions, please email your questions to mtanik@uab.edu.